Why is it automatically adjusting? All right, can you all hear me? Oh, FractalWoman's in the house. Uh, Hi, FW. All right. Hi, Lori. Okay, Lori's in there. Okay, doesn't even. Why didn't I not be able to do so? But hi, Lori. Okay, so there it is. And then okay, we got Daniel 333's in the house. All right, guys, can you all hear me? How's my audio? And why is it just adjusting? I don't understand. Why is it automatically moving? Let me go. Can y'all hear me? Yeah, I'm gonna check out my audience. I mean my audio. Yeah, hey, yeah. So you can feel free to join that link. I send you the link if you wanna talk into it. Me. All right, should be okay. Should be fine. I'll send it everywhere. I'm streaming actually on a bunch of stuff here on Rumble, Odyssey, and XYZ. I'm gonna post this everywhere now. This is on this X. Just post it here. Just occasionally someone yeah, occasionally some people comment. But anyways, yeah, so Dana 333 is my daughter. Okay, epic stuff there. And nice number there, 333. All right, welcome aboard, Dana. All right. Yeah, so this stream is gonna be yeah, it's gonna be basically if you guys have any math science related questions, but then the focus today is because it's gonna be on what in the world happened to Fractal Woman's channel here. So Fractal Woman, I think she's back on now. Yeah, so she's back on now. So apparently there is a Mr. X hassling her. All right, and yeah, so whenever you want to join in the stream, you feel free to join that link I sent. You can click the thingy. Okay, but okay, why does my microphone automatically change? I'm gonna do something. One second, I'm gonna do something. I'm gonna unplug this. Okay, just take this back. It's still adjusting it. I don't know why Teams is doing that. Audio's good, yeah, audio's good, but I just don't like how it's auto adjusting. Like, well, why did they do that? Last time I unplugged it and it worked again. Got no notification though. Interesting. Yesterday was when I posted. Yeah, YouTube is next level. But anyways, this is yeah, it's a Fractal Woman right here. And then basically what happened was somebody actually commented right here. We could I can go through the emails, some of it at least, if you don't mind. Let's see. Someone posted right here on my video. And this person says, yo, what's up with Lori Gardy, aka Fractal Woman's channel? It seems to have been nuked completely from YouTube. All her videos are on private right now. And you can't even find her channel without the URL. And even with the URL, it says it doesn't exist. She was posting till yesterday, every other day. Her webpage is also gone. Sorry for the off-topic comment, but it's kind of weird. Maybe you can get in touch with her since you already had a stream with her. Yeah, well, yeah. So and then I said, oh, yeah, what's going on? I'll email her. So basically, okay, there's okay, Fractal Woman's in the show. Okay, admit. All right, we got Fractal Woman in the show there. All right. Hello there, Fractal. Can you hear me?
Yep, I'm here now. Can you hear me?
Yeah, I can hear you. That's great.
Excellent.
And can you guys hear her? So, yeah, okay. What I could do is I could also share my screen. I'm gonna pin for me, pin for you. Yeah, so I'll share my screen just so we know what we're both on the same page. Include sound, Windows. I'm gonna go right here. All right. Yeah, so I can hear you. Can you hear me fine? Everything's fine on your end. So, yeah, so I can hear you. Evening, all. Guess we have a whole bunch of people in here. Okay.
I'm not sure how to get my camera to work. I don't know if that's important or not.
Yeah, I don't know why
It
it's not
should
showing.
work.
Yeah, it should work. Yes.
Let me see.
Yeah, take your time and no rush. We
Yeah.
have
Yeah, I will go
yeah.
to my settings and see. Oh. Oh, weird. How do I pick a different camera? I have a different camera, but it's not. It is plugged in. How do I pick a different camera?
I'm not sure. And I need to figure out my input volume stop adjusting. I just hate when it does that, and I have no idea how. I'm gonna unplug my mic.
Here, I am going to. Let me see. There we go.
No, it didn't work.
Is that better?
No.
I think I still need to re-enable it. Oh.
So I'll share your.
Shut this off. Huh.
Okay. I'm just gonna share your channel on.
Okay.
5 and the other setup.
Don't know. I can, like, my camera works. Works in, I'm just using the front face camera. I have another camera. Maybe I'll unplug that. Maybe it's confusing it.
Yeah, I'm not sure. It might be the
it's
team.
Working.
Okay.
On my computer, so yeah, you can just do that. You don't have to see me.
Okay.
That's me.
Okay, so that's
me.
Yeah. So she's a living, walking fractal. Yeah, that sounds good. Yeah, so your channel's back up. So basically, I was gonna say, is it okay if I read the email chain, or you don't want some of that stuff in there, or
which email chain?
The one our email chain, the one I asked.
Oh yeah, you can, anything we talked about, we totally.
Yeah,
you can,
and up to you if you want to use his name or not. I don't mind using his name. It was public, but
yeah.
So Mr.
Oh,
X,
it is public. I'm just don't want to.
Oh, you don't need to say his name.
Stroke his. I'm not gonna say his name. I'm not gonna, stroke his ego. Like, it's an ego thing. What's going on right now?
Yeah,
right. So
Yeah, but his channel seems a bit spook. Why does he have a guy with like AI using a fake like a mask on him?
Yeah. Yeah, that's a huge red flag. Like, that should have been a huge red flag for me. And I didn't, pay attention. And, I started the conversation. I complimented his work. I said, hey, I like what you're doing. I liked his experiments. I liked what he was doing. But, I wanted to promote it. I thought, this is interesting. There's nothing wrong with what he's doing. His experiment is something I hadn't seen before, but it doesn't mean it's new technology. You know what I mean? So I wanted to understand it. And once I wrote the program for it, I realized, oh, there's nothing new here. There's nothing new here. This is just the, Maxwell's equations. It's just standard magnetic fields, right? I used a standard tool called MagpieLib, which is really cool. It's a library that is for doing magnetic fields. So I just used that. It took me a few lines of code using that to replicate his images. And that's where things went bad, because he thought, if you read his paper, which I'm not going to do, he's, at one point in the paper, he says that the patterns he's producing are unpredictable, but they're only unpredictable to him because he doesn't understand the physics of magnetism. And so he got these images and he's like, oh, no one's ever seen these before, which may or may not be true. I don't know. But the way, so he did his physical experiments to do his physical renderings using a Hall sensor, which is also not rocket science, right? And so he's using a Hall sensor to generate these images. I was able to replicate it extremely easily, which I showed on my YouTube channel. And that's why, like, he doesn't understand copyright law. He doesn't understand copyright law. And so I would literally have to take a figure from his paper and publish it on my channel and say, I made that figure, for it to be a copyright infringement. Me using science to replicate his image to show him that what he's doing isn't rocket science. It's nothing new. There's nothing new in what he's doing. He's trying to say he made a discovery. Well, he discovered it himself on his own terms, but it's not a new discovery. That you understand the difference, right?
Yeah, definitely.
Like, I discovered a lot of things myself doing my own experiments, but I don't claim that they're, like, I discovered them first. So he's claiming he discovered this first. And that's where we ran into trouble. I tried explaining to him that, and that's where things fell apart, because he's a narcissist, and he took that as a personal attack, that I was personally attacking him.
Mhm.
Right. So that's where things went wrong. And, this is literally a retaliation, which is against the law.
Yeah.
I want to make this perfectly clear. If this person is listening, if Mr. X is listening,
Mhm.
what he did is against the law. He, defamed me. He basically said I was trying to steal his work because I was able to replicate it using my software, and I showed it on my channel, and I referenced his work. Somehow I'm trying to say, like, I'm the worst thief, if that's true, because first of all, I promoted his channel on my channel. Then I wrote the software and gave him the software. And then he's calling me a thief. Like, I'm the worst thief. If that's true, I'm the worst thief that ever existed.
Yeah.
So,
And
you know what I'm saying? Like, it's just weird.
it is, but again,
It's
he's
just
giving
weird.
me huge spooks, and also just for the audience, because
Yeah.
a lot of them aren't aware of this whole saga. Basically, this guy who runs the Quantum Arena. Is it okay if I say his name? You don't need to say his name. I could just say it for the audience.
Okay.
Yeah,
Yeah.
I'll just so that, at least one time, then we'll call him Mr. X after.
Okay.
So
Okay.
so his name is Marcio Salcuni. And we're gonna call him Mr. X. I was gonna call him
Yep,
Mr. Clown,
from now
but
on.
I was gonna call him Mr. Clown, but
Mr. X is, easier to remember.
yeah.
Okay.
Yeah. So he wrote this paper in July 15th, 2025. Magnetic orbitals, the first visual revelation of quantum geometries in the macroscopic world. So he wrote this paper thinking that he discovered some magical stuff here. And then his channel's called Quantum Arena, but he doesn't show his face. He has like some AI rendering of an alien. And his first video was 2
and
months
his
ago.
voice.
Yeah, well, and his
Yeah.
voice. And his first video was 2 months ago. And
Yeah.
interestingly, it's about polarity detector to visualize the real 3D magnetic fields, DIY Hall effect sensor. And this reminds me of like your stuff, because I'm like, you're the first one I've seen do Hall sensor.
Yeah.
Yeah.
Yeah. Yeah. And, I'm going to give credit to somebody else who gave me the Hall sensor so I could make these measurements. That's Carrie from the Good Vibrations channel. I don't know. I made some videos on him. I don't know if you remember. He's a good guy. He actually sent me, he built a Hall sensor that plugs into a voltmeter. He sent me the whole thing. He sent me the voltmeter, the Hall sensor.
I just want to. I accidentally had the sound on. Yeah.
Okay. Yeah.
Yeah, so I included him. Yeah, I just want to.
The isopotential, the magnetic.
Why does it? Sorry. When I'm
That's okay.
I was about to click mute, and then somehow YouTube has it like automatically pops the playlist button. Like every time I'm trying to just click it. Okay, sorry about that. So basically, yeah. Keep going. I was gonna show this while you were talking. Just so people know.
Oh, I like that picture.
Yeah.
Yeah. So like, I give people credit when they help me. When, like, the picture you just showed, so that that device there I got from Carrie from the Good Vibrations channel. The isopotential generator I got from Michael Snyder, that generator there, and that is where I started seeing the similarities between these images and the electron orbitals. And so I talked about it a lot. I made a few, quite a number of videos on it, showing the similarities using Michael Snyder software. I didn't write my own software because I was just using his, because it already worked. And so, and I did a couple of, I did write my software for some things, but then so the Magpie lib library that I use for magnetism, I actually used for the ferrocell simulator, right? So I don't know if you remember that whole saga with AB Science, and he was making fun of Ken Wheeler and stuff like that. And anyways, he gave me the code that he wrote to simulate the ferrocell, and he gave me 100% rights to it. Wow. He gave it to me. He was like working on his PhD, so he didn't have time to deal with it. And I wanted to publish something. I wrote a paper, tried to publish it, but like, it just costs too much money to publish things these days. So, I wrote the paper and put it up on ResearchGate. And, he, and Michael Snyder too, gave me a software, not the code. My AB Science actually gave me the code. and I was able to do different magnetic configurations. I actually even did the primer bowl. I don't know if you remember that one, but
Yeah.
for the
Oh,
ferrocell.
oh, you
For the
made that.
ferrocell. So
Yeah. No, I think I have
yeah,
seen
I
some.
made,
Some
yeah. I made my own primer bowl.
Yeah.
But anyways, like, we're kind of going all over the place here. But the fact is that people have been supporting me. People who give me things, and I give people things back,
Mm-hmm.
right? And so I gave Mr. X the first version of my software that did, remember the electron orbitals that I did that looked like probability dots, like spheres, little dots.
Yeah,
I made
I
that
think.
one video.
Yeah.
I took it down because
Okay.
he was harassing me. But anyways, if
So,
I could share my screen, I could probably show
oh,
you.
yeah, you can share. You can share. I'll stop sharing my screen.
Okay.
And then you can share
Okay,
whatever you
let
want.
me. Okay, let me. I think I have it up and running
Yeah,
here.
yeah, it's interesting saga. And also, John Hutchison.
here it is.
John Hutchison is in the house. Hi, John.
No, John Hutchinson?
Hutchison. Hutchison. Yeah. Me and him are like BFFs. I visited his lab. You can see the video I made.
I
in his lab.
remember that.
No,
Yeah.
I visited
God.
again. I visited again like a few weeks ago. The video's going pretty viral actually.
okay.
Okay, so you can have a look. Yeah, so Dr.
Okay.
John Hutchison. There's no N in there, so Hutchison.
Hutchison, sorry.
Yeah.
Hutchison. That's very important to get the name right.
Yeah, no, 'cause
Man, hey John, how's it going?
right.
He's kind of, he's the icon, right, of
Yeah.
weird science.
Yeah, definitely. No, and yeah, he might be
Yeah.
getting his lab back up, and I'll be the first one to film it
good.
if he does. Yeah, and
Oh, nice.
yeah.
Good job. Excellent. So how do I share my screen?
There should be a button that says like up. You should be able to share it.
I'm not familiar with Teams interface. So, there's share.
Yeah.
Okay, what I'm going to do is I'm going to move this over. It's better to do it in a shared screen, right? So I'm going to move this over to my other screen.
Okay.
And then I'll share that screen.
Yeah. And then
okay.
yeah, and once it's up and running, I do want to ask us. You actually gave him software, and this guy has the audacity. But
I know.
But it seems.
Okay, like I said, I'm the worst thief ever. I gave him my code.
Yeah.
And I did it, gladly, happily.
Yeah.
I was
not.
I don't know.
Yeah.
Anyway, so.
This is
can you see that now?
Yeah, I'm gonna make it big screen. Yeah, I can see it. It's actually amazing. Yeah.
Can everyone else see it too, or?
Can you guys see this thing? And also, if you could be a bit more just explanatory for the audience, because a lot of them aren't.
Okay.
Yeah, they're not.
Yeah.
Okay. Well versed on your next level. That's an amazing stuff. Okay.
Yeah. So what I did was in the little code on the left. Well, actually, this is just my visualization code. This is just used to visualize this. So I wrote a program in Python that used this magpylib, this magnetic field generator library to generate a bunch of points. So it just sparsely picked points in a field of view, calculated the magnetic field, took the normal of the magnetic field in the orientation of the Hall sensor. So in this version of magpylib allowed me to simulate a quote unquote Hall sensor, something like a Hall sensor, just a sensor, and could orient it in any orientation, whatever I want. And I just, integrated over the field and generated this image. So this is exactly what he was doing in his experiments, right?
Yeah.
He was, but it's not rocket science. It's literally a few lines of code to place a magnet in the field of view, pick a bunch of points and, generate the, what he calls orbitals. They look like orbitals. And I noticed this years and years ago that and these are potential. So this is not the magnetic field. This is the magnetic isopotential. And it's not even really a field, but it is a field by definition, I guess, but it's not the magnetic field. This is not the real. And this is where the title of Mr. X's paper is a problem, because he's calling this the real magnetic field, but this is not the real magnetic field. This is a projection of the real magnetic field. It's like me looking at you from the side and saying, oh, that's you from the side, and that's you from the front, and that's you from the top, and that's you from the bottom. They're different projections of the real magnetic field.
Okay.
So, you know what I'm saying?
Yeah, I just want to have some questions about this specific, this right here. Because, so how does this compare with the isopotential lines that you had before? So, and this would be, what kind of magnet would this be? And also, what is each
This,
point? Are
yeah,
they all different values,
okay.
or
Yeah.
why is there
So,
blue and red? Yeah.
are you allowed? Okay, so I'm sharing. Can people actually see this? Is everyone seeing this? I just want to make sure.
Yeah, they can
Because
see. They see this whole thing.
because
Yeah.
I'm okay. Let me. Yeah, I think I'm gonna switch to. I
Right.
want to see what you're seeing, so I'm gonna switch back to the YouTube because I was in the Teams actually, so I was only seeing you. So and I don't see.
If you go to YouTube,
Okay.
yeah, you should be able to see it.
Okay, I'm at the YouTube. How come I don't see it?
It's go to the end. You might be like not live, but the audience
Oh,
can see
there you
it.
go. You're right. I wasn't live. I better. I don't
Yeah.
want to hit the play button. Okay, I got to turn the sound down. Then I won't feedback. Okay. Let me go to the end.
But yeah, so the audience can see my whole screen, like even.
Okay, good.
Yeah, so don't worry about that. They can see
Okay.
everything. Yeah.
I'm having trouble seeing it myself. I don't know why it won't let me go to the end. Oh, I see it now. Good.
Yeah,
I just want to see what see
okay.
what you guys are saying.
Yeah, and they also see the
right?
comments
And
too.
so,
Yeah, so they see the chat
yeah.
as well.
Okay. So let me. Okay, I'm going to. Sorry, I wasn't really prepared for this. I kind of slept in and then I.
Yeah. No. Okay. Well,
so
yeah.
here.
That's all right. Okay.
Okay,
Yeah. So this.
things are kind of slow.
Yeah. So if you can
Okay,
like.
so let me.
Explain it's also with the mainstream magnetic field, which is the flux lines, and then versus the isopotentials, and then yeah.
Okay. Am I sharing? I'm only sharing an image, or can you see?
I see the whole. I see the whole
okay.
PowerPoint. Yeah.
Right. So the two images are the same. Okay.
Yeah.
My mouse is behaving strangely. It's like moving stuff all over the place.
Yeah.
All right. I'll let that catch up. And okay. So my mouse kept sticking and it was moving the screen around. So yeah. So the isopotential.
Also, those are isopotential. Also, the blue is also an isopotential, but from those. Okay. Yeah. Yeah. So
right. So it's a projective. It's a projective geometry.
Yeah.
So the isopotential here, basically, it's exactly the same code. Let's say it's the same code, only instead of just. So imagine with the isopotential here, the one on the left, I'm just picking random dots.
Yeah.
Instead of drawing the line. So each line here has the same voltage reading. Let's say if I'm reading with a voltmeter, it's got the same voltage reading. So let's say if the first one at the top is like 1 volt, the next one down is going to be 2 volts, and the next one down is going to be 3 volts, et cetera, right? So this whole line would all have the same voltage if I was using a voltmeter to read it using a Hall sensor, right? So this one here, it's just the dots are just random points in the potential field instead of making nice, beautiful lines. The equations are the same. The code is identical, except that I'm picking random points instead of, and so the dots, are like this particular rendering is a projection. The isopotential that Michael Snyder's code generates it's hard to explain. Each point, the Hall sensor has to be oriented. Okay, I know how to explain it.
Well, this one's on a flat plane, but even on 3D, it'd be like a mushroom. Yeah, in 3D, it'd be like a mushroom.
So I'm going to move this over. So you see these arrows here.
Yeah.
Right. In the one on the left, that's the normal magnetic field. That is the real magnetic field. And I'm going to tell you that I used to think the isopotential was more real than this, but these are actually both real, right? These are both good, real renderings. They're two different faces of the same magnetic field. They're two different ways of looking at the same magnetic field. This way shows the vectors, right? They show the direction of it. Let's say you placed a tiny magnet on one of those arrows.
Yeah.
Right. It
lines up.
It would line up. Right. So if you took a Hall sensor and lined it along the magnetic field, so the Hall sensor, the flat face of the Hall sensor would actually be orthogonal to or like lying on the isopotential line.
Yeah.
Right. And then if I took a reading at each location, then I would get the isopotential. Line like that. So with this one, it's more like a projection. And so what he does, and it's commonly done like this. He's not the first one to do this, I can tell you. The Hall sensor, he keeps in one orientation, right? He keeps it in one orientation. Can you see the magnetic field on the left?
Yeah. Those
Okay.
are the flux lines.
So
Yeah. But
if the Hall sensor say is,
but
horizontal.
but you're just mouse. I can't see your like. Do you have a mouse that you're pointing at or no?
But it's not. It
doesn't show. But
it's not working.
I'll use my mouse whenever you're
Okay.
this.
Okay. Yeah. So why doesn't my mouse
Oh,
work?
oh, there it is. I see it now.
Oh, I have to be in. I see. I have to be in your window. I have to. You see it now?
Yeah, I see it now.
Okay. I
Yeah.
go to. Oh, that's weird.
Yeah, I don't know.
I don't know how to.
Oh, you have a duplicate?
I'm on two screens. I have two screens, so I don't. When I'm in your screen, I can see.
Yeah, the mouse.
Like, can you see when I look at YouTube? Oh, I have to.
Yeah, no, I can see your mouse now. When you...
I forgot to hit play again, and to get to live. Okay, now you can see my mouse. You can see my mouse.
Yeah,
now?
I can see.
Okay.
That was good.
Now, am I pointing to the N?
You're pointing on the left side. Yeah, on the dark nothing.
Oh, okay. I see what's going on here. My mouse isn't lined up with. It's not. This is weird. I don't know. I don't know Teams enough to really know what's going on here. I don't know if I need to
I don't know.
go like full screen, or do you see my mouse at all here?
No,
right
you can go full screen if you want. It'll probably be better, like in terms of the PowerPoint, because right now it's like it shows the ribbon on the top.
Okay.
Yeah, so just make it bigger.
Right, there we go. All right.
Or even like a full screen as well. Would that even work? Because right now, I like presentation mode.
Yeah.
Does presentation mode work or no?
Oh yeah, I can go. Yeah, I know what you're saying. I can go full mode. There we go.
Yeah, this is pretty good. Yeah, that's pretty good.
Okay, that's better.
Well, yeah, your mouse is, I can see your mouse. It's doing stuff.
Okay, so am I around the N?
You're on the left side. Yeah, you're on the left side of the flux line. On the left line, going arrow down. Now you're to the right. Yeah.
I think I'm just not. I'm
okay.
I'm out of sync.
Okay, go to the North Pole. Yeah, go to the North Pole and see what happens.
Okay, I'm at the North Pole now. Any luck?
No, you're at the middle. You're at the block wall on the left, where the arrows are. Yeah, you're on the.
I think there's a delay. Is there any way I can do this in Teams and not on YouTube? I'm on YouTube right now.
No, don't look at YouTube. Just ignore YouTube.
Yeah, okay.
You could
okay,
just like close
I'm good
it.
now. I'm back to Teams. Okay, how?
Oh yeah, I didn't know what you were on. Yeah, no, you just go on Teams and yeah.
Yeah. Okay.
Like try to try to highlight the wrong animation. Can you highlight that just to see the text on the bottom?
Okay, I'm circling the N right now.
I don't know. You're circling on the left side of the block. You're.
That is weird. I don't understand.
Yeah, I don't know what's happening.
Okay. Anyways, I think I can talk this through. So the
Yeah. And I can use my arrow whenever you're describing something.
Okay. So if you point to the arrows at the top.
Yeah.
If you point to the arrows now, I'm seeing. Okay, let me go back to the YouTube then.
Well, YouTube's gonna be a bit delayed, like a few seconds, but you can.
Oh yeah, you're right.
Because it has to relay the entire internet.
Yeah. Am I on Teams or am I on? Okay.
Yeah, and also, Beneficent TV is in here. He says, "Hey, Fractal Woman, big fan of your work." So Beneficent.
Aw. Yeah, okay, so are you pointing to the end right now? Because that's what it looks like.
Yeah, I'm pointing at the North Pole, pointing up. Yeah.
Okay, just above. Okay, so nice. We're in sync again. Yay. Mm-hmm. Okay, so near the top, let's imagine that the Hall sensor is like pointing down.
Yeah.
Pointing down. So it's sort of perpendicular to the field lines. And so the other image that the, dotty image, the image with all the dots that I made, I didn't reorient the Hall sensor. I keep it parallel and then scan, then I pick all my potential points all the way through. So the only thing I don't do, and this is what Mr. X does, is he just keeps the Hall sensor parallel and he scans, and then he gets that other one with the tube in the middle. right? Then he gets the other one with the tube in the middle.
Oh, so the Hall sensor depends on the orientation. So because the other one you were rotating it. Oh, so that's all it is. So that's all it is.
Of course, that's all it is. Yeah, and so, yeah, that's all it is. So that's what he's doing, and he's claiming that he discovered that, and then he generated those pictures. You know, pictures like physical models. Actually, he made a physical model, and
that's interesting. So the Hall center making it perfectly parallel the whole time. You're gonna get a bit of a skew actually, but that's
you're gonna get a different picture,
But it just seems a bit because yours you would orient it like you would always rotate it along the line, so that you have the same
that's
strength.
the my like basically this is the real isopotential.
Yeah.
I'm gonna go. I know this is like I'm flipping back and forth on you. Sorry.
Yeah, no, it's all good. I understand. Yeah.
So what do you see right now? Do you see the dots or do you see the
no,
magnetic field?
I see the magnetic and isopotential. Yeah.
Okay. Yeah. So the one on the right, which is from Michael Snyder's software, always reorients.
Oh, so it's pointing to the poles like at all times.
Yeah. And then it's pointing towards the poles, I guess you could say, but basically you want to think of the Hall sensor as being orthogonal to the magnetic field line. So let's say it's lined up with the magnetic field line, and or you could say it's sitting on the isopotential line but pointing to like normal to the isopotential line. The axis through the Hall sensor is normal to the isopotential line or parallel to the magnetic field line. So it depends, So these are two pictures of the same. These are two pictures of the same magnetic field. This is the real magnetic field. This is the isopotential of the real magnetic field. And what Mr. X is doing, which he's calling the real magnetic field, is just a projection. So when he has the Hall sensor, holding it in one orientation, he's only seeing one projection, and it creates a different. It creates a different picture.
Yeah.
It creates a different picture. And so if instead of going top to bottom, we went front to back.
Yeah, what would happen? Or side to side, or side to side.
Yeah. Well, front to back and side to side are the same because the magnetic field is cylindrically symmetric, right? So if you go front to back or left to right or even 45-degree angle, you're going to get the same picture. But if you go top to bottom, then you get the picture that I showed you, with the tube around the middle for one magnetic field. Now there's all kinds of different configurations, right? Let's see if I have any.
Yeah, that's what I want to see. It'd probably be easier to visualize. So you have these dots. If you adjust which Hall sensor angle is on the dots, this one here.
Yeah.
What would happen? So this one is.
You get a different picture.
Yeah. So right now, where is the Hall sensor? It's going parallel. So the Hall sensor is going from left to right. Like how are you moving the Hall sensor?
Yeah. So for the one with the tube in the middle, the Hall sensor is going from top to bottom.
Yeah. So
like it's going vertically in the Z direction. So if up and down is the Z axis, if the middle going up is the Z axis, the Hall sensor is going top to bottom.
All right. And it's meant to go top to bottom, and it never rotates at all. So
not at all.
Yeah. Okay.
No.
And then you get this image.
Yeah. And so in his videos, if you watched his videos, you'll see he's doing scanning. He's using the Hall sensor and scanning on a plane, on a board. He calls them boards. He's scanning on a board, and that's how he keeps the Hall sensor parallel. Right. So, and then he does it for different depths, and he is able to produce a 3D-ish kind of model.
Yeah.
Which he did physically. He built physical models. He did just a few slices through, and put them in a box or something. Put them in, attached them together, and then presented those. And so, yeah, I never did that before, but I don't really want to do that because it's a lot of work, right? But that doesn't mean it's rocket science. Just because he did something a different way than other people did it doesn't mean he can claim ownership of it. This is a scientific principle. Scientific principles cannot be copywritten, right? But he thought so. He misunderstood the copyright laws, and he thought that you know, he had ownership of it because he thought he was the first person to do this, and he thought it was unique. And, you know, he wrote a copyright symbol in his paper thinking that, yeah, his document is copywritten. And if I took a figure from his paper and put it in my video and claimed to be the owner of that figure, that would be copyright infringement. Right?
Yeah.
If I cut and pasted his text and wrote another document and used, like, plagiarism, used his text word for word and wrote a paper and tried to publish it, that would be copyright infringement. Right? You cannot copyright scientific principles. You cannot copyright the laws of physics, for God's sake. Like, you know, and it's just weird. It's narcissism. It's delusions of grandeur. He thought he did something that he was going to get a Nobel Prize for, and I busted his bubble.
Oh wow.
I busted his bubble, and it hurt his feelings, and that's why he's retaliating against me.
Yeah, that's yeah, it definitely looks like that. But again, he also, I think that there might be an angle of the spook angle, because I think you are onto something big. That's why I made videos about your work, because it just simplifies this.
Thank you.
Yeah, because it's whenever you can simplify magnetism.
Yes.
Because right now mainstream is like it's literally mystical.
Yeah. I have a great, like, I'm going to make another video. Well, I wanted to make another video, but now I'm a little bit scared of Mr. X, because, you know, I'm already have like 2 strikes. And if I get 3 strikes, they'll shut down my channel. Right. And so it's not really fair. It's not fair because he can just say copyright infringement. They have to shut down the video. And then in order for me to defend myself, I have to give him my address and phone number. I have to, like, in order for me to file the what's it called, the
appeal or the appeal or whatever.
The appeal, or whatever. It's a note, like, what's it called again? Dana, what's it called? Help me. The claim. What's it called? Anyways, in order for me to defend myself, to fill out the form, to say no, he's wrong. This was 100% my content. I have to put my address and phone number into the form, and he gets that.
Yeah.
He gets that, because if this is a real, like, let's say I did infringe on someone's copyright, they could sue me, and in order to sue me, they need my address and phone number. Counter notification. That's it. Thank you, Dana. Counter notification.
Or
in order for me to file a counter.
Yeah, counterclaim. She says counterclaim or counter notification. Okay, counterclaim.
It's actually called a counter notification.
Okay.
At least that's what ChatGPT calls it.
Okay.
Yeah.
Yeah.
So that's the problem. So it's very difficult for me to fix this and to defend myself, because I don't know who this person is.
Yeah.
I don't know what they're capable of. They're hiding behind a mask on their channel.
And it's new. It's like literally 2 months old channel.
Exactly. Exactly. So I don't know what, I'm kind of, Dana and I have been talking about different ideas, and, at one point, well, what I did, why my channel went down wasn't, they didn't take it down. YouTube didn't take it down. I took it down because once I realized he took 2 of my videos down.
Yeah. So.
And I knew that 3 videos would be,
that's right.
3 strikes and you're out. So I I hid my channel, made all my videos private, so he couldn't touch them. And then I couldn't get it back up because I had strikes against me. I couldn't get into YouTube Studio to turn it back on.
Yeah.
So I had to jump through a bunch of hoops. I didn't even know what to do. It took me half a day to figure it out. It was weird.
No, yeah, definitely.
So,
and can you see my screen? I'm sharing it right now. I just want to understand what is he actually copywriting, and you, because you made a video. What did you like? You just talked about stuff. That's copyright.
I was reviewing his paper. Basically, I was showing how I was able to create software to replicate his figures. That was it. That was it. And I went through, I don't know if you watched the video, but I went through, showed how how I wanted to make it clear that what I had done previously already to show what my contribution was, which was the Hall sensor, measuring the isopotentials, blah, blah, and all that stuff, right? You know
Yeah.
that I did all that stuff before.
Yeah.
Okay.
Can you see my video right now? I'm showing what he's doing with the Hall sensor, or just a physical magnet.
With the magnets.
Yeah, magnets.
Yeah.
But why? It looks interesting, but why is he saying it's all like world changing? I'm not sure.
I don't know. He thinks he discovered this. What he's showing right there is perfectly normal for a ring magnet. And so when I simulated the ring magnet using my software, it showed the exact same pattern that he sees there. Okay, so the blue region is the South Pole.
Yeah.
The red, and everything he has in red. Okay, it's not a pole, but it is a pole. Like it's
for mainstream term.
Plus or So blue is south. So let's put it this way. Everywhere he painted blue, everywhere I paint blue in my software, the Hall sensor thinks it's a South Pole. Okay, and so can I put my magnetic field back up?
Yeah, I'll just stop sharing.
Yeah, once you're done,
No,
we can talk about this a bit, and then I'll explain.
Yeah, because I just want to give more context to people, because right now actually I'll keep sharing my screen just to illustrate, just to a big overview. I'll read some of the email stuff, or I actually think we don't need to read the emails, but we can go through here. So this guy here, I just want to and you can correct me where I'm wrong, just to summarize it. So this guy right here creates a channel, publishes a paper in July 2025, and I'm not sure if he has any other papers. Actually, no. There might be. Oh, he has one.
There might be one, yeah.
Oh no,
there might be a book.
Just him. There's no paper on the website that he posted.
Oh, I see.
So there's two. I think he put one of them in Italian, or what language is this? Translate.
I think it sounds like Italian.
Yeah, how do I translate? I'll Google Translate.
I think it's Italian.
It's Italian, yeah. So have the shapes orbitals. So and also that magnetic one where he's like forcing it upon the tube. It is interesting, but again, it's not world changing. Yeah. So this one, but if you search his name up, he has some interviews he's done like years ago, I think, on YouTube. Marcio Salcuni. So I kind of like deep dive on people to just to understand who they are, because I'm telling you, there's a lot of spooks. So he has that channel he created recently, but there was one where he was talking in an interview, I think it was years ago. Marcio Salcuni, Quantum Marina. Okay, so there's nothing on here. No, this is okay. It looks like JFK project. Okay, no, this is guys 12 years ago talking about the JFK project. I'm not sure if it's the same person.
Okay,
but it might be.
Probably not.
But it's the exact same name. That's an interesting name.
Well, I'm sure it's like John Smith in in Italy.
Yeah. Okay, yes. And anyway, so this guy, So far, what we know is he posted this, and then he uploaded November 19th was the English translation. Oh, uploaded November 19th. Oh, but it was published July 15th. I don't know what that means. That's when he sent it, but it was uploaded November 19th. Oh, there's 5, or probably the latest version. Anyways, so that guy there claims to have found new magnetic field stuff based on just graphing out how the magnets / Hall sensor behave around this, and then he did some software to show that. I just want to see his.
No, I did the software. He never did the software.
So you made the software for him?
I did. He never ever all he did were experiments. So all of his pictures are from his experiments. He hand drew all those.
Okay, and is there
with his experiment, which was cool. I like his experiment. It's cool. But he did it. I could do it too. Like I did it basically like what I did years ago with the Hall sensor and plotting those points and showing, I can reproduce the isopotentials. He did. And he just made his pictures look prettier than my pictures.
Okay, so he just made this. This is his first video detected. That's a Hall sensor. And then I just want to see his most popular one. It was probably the latest one. Yeah, okay, so 6 days ago, hidden geometry of magnetic fields.
Yeah. And
he's only using a ring magnet there for some reason.
Yeah. Well, ring magnets are cool.
Okay.
Ring magnets are
Yeah.
really cool. That's why, like, he
Oh,
thinks he discovered something special about a ring magnet.
yeah. Oh, so that's the shape there. You know, so basically this shape is the
yeah,
ring magnet. What if you used a normal magnet? Would it give this, or it
the
wouldn't give this?
normal mag
Would
the
give,
more normal magnet is like what I showed you.
yeah.
The normal magnet's what I showed you.
the
Like the
I
ones there, yeah.
yeah, on the
The
right.
ones you see on the right, yeah.
Okay, okay, yeah. So
Yep.
so basically
Yep.
nothing special. Yeah,
Yep.
I thought he was
Yep.
producing this from a normal magnet. Okay,
Yeah,
so
the one
nothing.
on the right is a normal magnet.
Okay, so
The one on the right is a normal magnet,
so he did nothing special.
right?
So yes. So the question
He
is,
does some of
yeah.
the experiments he does with two magnets, so north, like either in repulsion or attraction. And I simulated all these with my software. So everything he does, I can 100% do, like it all 100% looks
Yeah,
correct.
and he's drawing this manually. Yeah.
Yeah. So yeah, exactly.
Okay,
So
so
you know,
nothing is special. Like I initially
no,
I thought
no.
something special because I thought this was a normal magnet, so it's a ring magnet. Ring magnet. That's
No,
like
no,
whatever.
that's a normal magnet.
This one's a normal magnet. No, this one.
All of his
Yeah.
stuff, except for the recent videos he made
Yeah.
all of the ones were just one or two or more maybe, but I only saw him do like one. So that's the one,
Yeah, but then he has this drawing on the
right?
right.
Those
That's
are the,
yeah, but this is a drawing on the right.
yeah. So okay, the drawing on the right is what I showed you
Yeah.
with the Hall sensor going top to bottom,
Oh,
but not
not
reoriented.
but of a normal magnet, of a normal magnet.
Yeah.
Not.
These are all these three pictures that you're
Okay,
showing.
okay,
Go back
okay.
to the three pictures, okay?
Yeah.
The one on the right is what I showed you with the Hall sensor just in one orientation, going
Yeah.
top to bottom. The one on the left is going front to back.
Mm.
The one in the middle is reorienting all the time.
Okay. Oh, yeah.
Is Michael Snyder's, like that. Those
Yeah.
are the normal
That's the
isopotentials.
that's the ones you turn
Right.
perpendicular to.
And I mean normal in the mathematical sense, where the Hall sensor is normal to the isopotential line or parallel to the magnetic field line. So the one in the middle is
Yeah.
the Michael Snyder way,
Yeah.
the normal way. Like that's the
Like this.
real non-projective isopotential that I was showing in all my videos.
Yeah, because this
The one on the right,
like you see this image right there. Yeah, that's the one I made this thumbnail.
Yeah.
This is well, you made it. I just made it bigger and use upscaler.
Yeah, so he's mimicking that. He's
Yeah.
mimicking that with the middle one.
Yeah. And
Right.
then and yeah, so that's what I mean by
Like that.
and these are projections because your same is the same orientation of the Hall sensor. That'd be interesting to.
Well, the Hall sensor, okay, so in this case, so this picture I like, you can think of each magnet, the little magnet. So this is small magnets in the vicinity of a large magnet. I like to call, that's what I like to say. Like all the stuff I do is small magnets in the vicinity of large magnets. So the Hall sensor you can think of as a small magnet in the vicinity of a large magnet, making a measurement.
Yeah.
And so if you go back to the picture with the magnets, the one you just showed a second ago.
Yeah.
With the magnet, the big magnet and the little magnet, and Michael Snyder's.
In this one, because I was gonna show where you actually had little tiny magnets there. This one here, the little magnets, and there's the big magnet.
Yeah. So each of those little what you doing there? Okay. Oh yeah, there's me. You're jumping through a lot of stuff.
You're watching the YouTube, right? Because I'm sharing the screen.
No.
Are you watching the screen, or because I'm not doing anything right now?
Oh, what am I watching?
I think you're watching the YouTube.
Why? Why would I do that?
Yeah.
Okay, what are you showing now? What are you showing now?
No, I'll just showing the. So if you don't look at the YouTube, just look at the teams because the teams is like real time. YouTube's like delayed 5 seconds. I'm showing the small magnets in with Michael Snyder software in the vicinity of the big magnet.
I just don't know where my Teams is, truthfully. Like, is Teams a program that I'm running on my computer? I'm a little confused.
Well, you have Microsoft. There should be in the bottom. Well, yeah, I use a Mac now for some reason, so I don't know.
Okay, I am stupid. I'm a computer scientist who's really dumb at using computers. I'm sorry about that.
No.
I'm bad. I'm where we should be right now. Okay.
I remember in IT.
Can you see my mouse?
No, I'm showing mine. No, I'm showing my screen.
Okay.
Do you want to share yours?
Oh, that's right. No. Show that. That's good. So each of those small magnets you can think of as a Hall sensor in his experiment.
Yeah.
So each of those magnets, if you lined up the Hall sensor in the same orientation as each of those magnets, then you're going to get the maximum potential measurement. That's where, if I place a magnet in any of those locations, it's going to want to align in that orientation. It's going to want to sit, say, on the isopotential line. And you can see how all those small magnets are like orthogonal to the isopotential curves, right? You can see that, right?
Yeah.
So each of those little magnets is orthogonal to the isopotential curve. The isopotential is orthogonal. They are orthogonal to each other, right? And so this is the normal, in the truest sense of the word normal, where the magnet is normal to the isopotential curve and vice versa. You're a mathematician, you know what that term means, right?
Yeah, perpendicular, yeah.
So this is the normal isopotential field in the truest sense of the word normal. This is the one that I was, showing for the most part, because Michael Snyder software only does it this way. The only reason I didn't do it the other way is because I was too lazy to write my own software to do the isopotentials. And then I realized, and I was talking before about the ferrocell simulation. I realized, oh, I can use the same magpie-lib that AB Science used for that software to do the isopotentials. And so that's, but, after watching his video, I thought, oh, I want to simulate this, and I have all the tools to do it, so I might as well just do it. I wasn't like trying to steal anything. I was just like, oh, I know exactly what to do. It only took me, a few hours. I actually had ChatGPT help me, because you have to match up the version of magpie-lib with Python, and that gets a little, when you try to match up toolkits, you have to. So it helped me do all that, and then I already knew how to use magpie-lib, so I knew what to do. And then I got the software running really quickly. I showed him the first rendering. I made that little video called Magnetic Orbitals, which he made me take down.
Oh, yes. Yeah. So basically,
anyways,
you showed. So yeah, just to get this straight. So he's doing all these drawing these. He's doing physical measurements and experiments, and then you just used the basic tools that you already had to just replicate this in 3D.
Yep.
And then he's saying you copyrighted his discovery.
Yes.
Okay. So definitely.
That's 100%. You got it straight.
Yeah. Okay. So that's all that is. So I thought
I know.
I thought he was trying to say you stole his software, but so it's your software.
No. Sorry. No. I know. It's
your
even
software.
Worse than you thought.
So it's your software, and it's magnetic, and it's just basically.
He never used my software.
Oh, wow.
Of course, I used my,
he doesn't seem like
none
he
of
would
his
know, he doesn't seem like he would know.
He can't. Oh no, he doesn't even. He admitted to me in his email that he doesn't even know math. That's why he has to do these experiments. He can't do the math. He can't do the math, and he doesn't understand magnetic fields. If you read his paper, you'll see that he doesn't understand magnetic fields.
Yeah, but
and so without understanding magnetic fields, this is going to seem strange. When you do these experiments, it's going to seem strange.
Yeah, but it's a 215 page with like big text.
I know.
Yeah, it's.
I know.
He probably used ChatGPT, or again, I think Spook.
I don't know. It doesn't look like ChatGPT to me.
Yeah.
Maybe for parts of it, it's not even until like a ChatGPT would have done a better job.
But it's pretty big text too. Like this is big. Like one page is just like 8 lines.
Yeah.
Okay.
And he's connecting it to make did he get that from me? Now I'm starting to, think that maybe he got the matching magnetic isopotentials to electron orbitals from me, because I was talking about that years and years ago. I can do the same thing with Michael Snyder software. I just can't do those extra projections, which he was able to, which he found,
Okay.
So I just didn't think to do that. It doesn't mean that right? I just didn't think to do that.
Yeah, but it's interesting how they line up like in symmetrical setup like that. And he has a weird logo here, or weird thing he has in his
I know.
PDF.
I don't know. I don't know what that is. That's at the end of or beginning of,
Yeah,
like
so
any blank page has it. Yeah.
but again, I've like my spook detector is it's pretty high.
Yeah.
So and this is the other part I was trying to say, like, is because you're only posting on YouTube. Like, have you posted anywhere else? This is when I was trying to get you on 3Speak, but even like Odyssey, Rumble, or anything, or BitChute, just so you don't need to
I
rely.
yeah, I
But
know.
the only
He
one,
could go there
yeah.
too and do the same thing, right?
No, not on. He can't do that on Odyssey. No, Odyssey. The only one he can't do it on is 3Speak. Like literally, but the other ones they wouldn't be able to. YouTube, none of them will listen. None of them will listen to him. YouTube's the only one that's like has like automated setup. But
Okay.
but the one that
So what about Rumble? What about Rumble?
Rumble is something they yeah they're just more free speech oriented. But they're all centralized. What I mean is if he takes it to court, they would have to listen. The only one that they wouldn't have to is 3Speak. That's the one it's on
Okay.
high. But this is the paper that. I know Dino. I emailed him asking him if I can post it on the Hive blockchain. Like these are the ones where you can't even delete it. Like I can't even delete my own post.
Oh yeah.
So even if the
And what?
government says delete it, oh well, I can delete it on the front end, but the back end anyone can
Okay.
access forever.
Oh, I see.
So that's kind of what I was trying to get you to get on.
Okay.
So you see this paper, you've read this paper, right? I think you've.
Which
Is it?
is that Yonel's?
Yeah, this one
Or what is that?
I emailed you. So I know Daniels. Yeah.
Yeah.
Yeah, so fundamentals of the Ether part 4. I really liked it. I was gonna go over it, and then I asked them if I can just publish it here, because again, I don't trust the mainstream sites like,
Okay.
but also I don't like the orientation of just a PDF and on ResearchGate and all that, because ResearchGate.
Yeah.
So I'm basically making it
Oh,
into an
there.
article. Yeah, so this is the paper.
Yeah. So if you go back to the other one, you'll see that I co-authored
Yeah.
a paper with that one there.
No, your reference,
Yeah.
your
Oh,
reference
good.
lower in
Yeah.
here.
So I wrote all like I
Uh,
simulated all of Yonel's stuff.
yeah, and
I simulated all his stuff, you know, and you know that you've seen all
yeah,
the,
so you were part
you
of
know, those were
the
cool.
part 1, yes, part 1 of it.
Yeah.
Yeah,
The
so
part one. Yeah.
So I really think he's onto something, and you as
Yeah.
well, and then also
He
yeah, got
for
into
sure.
contact because of you. So I'm like I cannot
Good.
pinpoint
Good.
the thing. Yeah.
Yeah. Yeah. I have to actually go back and reread the paper that we co-authored because
Yeah.
as I learn more stuff and get more, you know, sort of
Yeah.
grok knowledge, you know, real and a good intuition for it, then I get different insights. And so I often go back and read a paper because I'll get more insights than, you know, the first time or the second time. So you know, his work is really good. He did some simulation using finite element modeling or some sort of, you know,
Yeah.
you know, and that was really cool. And I don't know what he's working on right now. He said hasn't done anything in a while. So he was the first one to email me and say, how come your channel's down?
Oh wow.
And I was really surprised, like, because I hadn't heard from him in a while. So I'm like, I didn't think he was paying attention to me at all, but
Yeah.
somehow he figured out that my channel was down. So
Yeah.
and then you did and other people did. So
Yeah.
yeah, and I really super appreciate your support.
Mhm.
It gives me, at least I feel like someone has my back,
Oh yeah, yeah.
right? And
Okay.
I really appreciate that. So thank you for
Yeah, anytime,
for
anytime.
doing this. And it is kind of nice to talk about this and get it off my chest kind of thing. So yeah, I really appreciate it.
Yeah, anytime, anytime. And I understand the frustration, like especially as because again, I have like spook detectors everywhere. There's people.
What do you mean? What do you mean? Like you're just your internal spoof detector? Is that what you're saying?
Yeah, well,
Your
yeah,
gut instinct? Is that what you're saying?
yeah, because I deal with a lot of spooks here, especially when dealing with the 9/11 topic, or even the Hutchison effect. So
Yeah.
like I made so here's just to give you an idea of the spooks. So if I go to like a Hutchison effect, so you know Robert Murray Smith,
Yep.
yeah, so
He passed away recently, right?
yeah, so I'll explain some of that. So he's a spook.
Okay.
He's a spook.
He was?
Yeah,
He
so
was, for
yeah,
sure?
yeah, he
Oh.
definitely. So he did a video, quote debunking Hudson effect, and then he used deceptively muted audio of a video that John took. Wasn't even about the Hudson effect, and he was using another spooks guy, Ace Baker. So this guy is using deceptively muted audios. If you look at it, but I'll just give you some interesting stuff. So he's definitely a spook.
Okay.
Yeah, but so this guy here, Ace Baker, he also is a spook on 9/11. But anyway, that's for another day. But this guy here, He's the original one in like 20 or like 15 years ago. He made the deceptively muted video. So basically, they would mute the audio that John was saying to make it look
I
like
see.
to make it look like he was using a string. But it was actually a high voltage wire, and he was trying to replicate
Oh.
Thomas Townsend. Yeah,
So if they didn't mute it, they would hear the
yeah,
noise,
yeah,
right?
yeah. They would
Huh.
hear it. It's talking about it wasn't just using high voltage wire, and like he was using literally high voltage wire. John even says it in like 2009. And then he made a video saying these cyber stalkers are attacking him, taking out the audio, reposting it all over. So anyway, so that's Ace Baker. Then Ace Baker, on a side note, he also faked his death on a live radio TV show for some reason. And then later, then he got this guy's this other spook's radio show shut down because he was hosted this guy faking his death. With him faking it, shooting himself, and then he's back up, and he said it was performance art, and he had mental issues or whatever. But anyways, we're going further. Robert
That's
Murray.
crazy.
So Robert Murray Smith, I made this video last year, and then this year Robert Murray Smith, literally a few months ago, committed suicide. So what are the odds? The two people that I made
What?
videos, yeah. So
I knew he
yeah.
passed away, and that's why he made the final video, because he was going to commit suicide.
No, that final video was published
Yeah.
after he committed suicide. So he scheduled it to post. So apparently his wife died last year, and then he was really depressed. And then he took the apparently he got a I don't know what, but apparently according to his brother, if you see this last video, is his brother talking about. If you go to Robert Murray Smith, if you go to his channel, the last video before he posted was actually his brother. So this is brother describing. So Robert Murray Smith, his brother's talking. This was his last video. He actually died before this video. You can see the picture of his wife in the back.
Yeah, I saw the video.
Yeah. Yeah, but he was a spook, because again, I'm like John Hutchison's bodyguard. Anybody?
Okay.
And
jeez.
and again, there's a lot of spooks that even go after me. That's for another day. They do hit pieces on me.
Yeah.
But
I guess I should consider myself lucky. I
yeah.
have had a few, but
Yeah,
I don't know.
Well, because it is again, it is important stuff. Any knowledge about magnetism, because I think like anti-gravity stuff do exist, and it's just like just a slight re-examining magnetism and so on.
Okay. Can you go back to my magnetic field picture with the arrows if you have it?
Oh, yeah. I want to go to that.
I just want to
you have
tell
it,
you how simple.
Which arrows? The one that the one you were showing?
You don't.
On your
Okay.
what's on
Can
the
you
PowerPoint?
just find a picture of normal magnetic fields and put it
Okay.
up?
Yeah.
If you just search for one, it doesn't really matter which one. I'm just going to tell you.
It's in here. Yeah.
How simple.
Here's the well, this is the loop one. You want the other one? This is or you want the normal?
Just anyone. Like the normal though, with the arrows. Just like.
Well, can you see the one on the left? That's a normal one, but that's a coil.
Okay.
Yeah.
Yeah. No, if you could just find like a magnet in the vertical orientation, just so it matches my.
Yeah.
Just do a Google search.
Let me go right here. Magnetic field wiki.
I'm just gonna tell you how simple this whole thing really is.
They're all using that. Okay.
Yeah. You don't even need a Hall sensor or a computer program to draw those pictures.
Don't they show anything? Magnetic field.
There we go.
Or you want one of these, or
any one of those is good. Yeah. Even a charge field is good.
Okay, I think.
Just something with arrows. Okay.
Or this one here. Charge
no,
field.
do a magnetic field. I want it in the vertical orientation where north is up and.
I don't know why everything's so hard. Like every single one is sideways. Yeah, when we want it, it's all.
They always do it sideways.
Okay, let's go magnetic.
That kind of sucks.
Magnetic field.
Just do a Google search and go to images.
Yeah, let's go to images.
And I'll tell you which one I want.
Let's see, magnetic field. I'm using a pre-search. Okay, pre-search is I use it because I earn crypto, but anyway, that's for another day. Okay, I'll switch over to here. Okay, every single one is horizontal.
I thought I saw one vertical. Oh, you're right. Why?
I think we're in a Mandela effect. I think there never was a.
It doesn't. Okay.
I'll say vertical.
Should I share my screen again? Okay.
Well, we will.
Say vertical.
Yeah,
say vertical.
Yeah, I said vertical.
Say vertical.
I just wanted to see if there was one. Okay. So there is.
Any one of those is fine. Any one of those is fine.
Yeah, I'm just gonna open up a new here. Here's a old
Okay.
school one. So
Okay. Okay. So, so now you see arrows pointing up, arrows pointing up, arrows pointing down on the left, arrows pointing down on the left.
yeah.
Okay. Now, if you color all the magnetic field lines with the arrows pointing up, you paint them red. So if you
Yeah.
see an arrow pointing up, you paint it red. Now
Mhm.
you can imagine those, there's arrows all the way along the field line. So paint, if they're pointing up, you paint them red,
Yeah, I'll do that.
right? Okay.
I'm just gonna just paint them
Or
pan.
just sort of just draw a circle around, where you see up arrows.
Yeah, I'm just gonna do some stuff here.
Right.
Okay, so I'm
Okay.
gonna draw this. I don't know, you probably won't be able to see the screen until I save it. And then afterwards you want to do blue on the other side?
No, every time. Yeah. So see at the top, you see a few arrows, like draw a circle from the magnet around those 3 field lines that you see with the arrows pointing up.
Okay, yeah, because you won't be able to see it, I'll do this. I'm gonna go
Okay.
to see if I could find a online image editor. See if it online.
Oh yeah. I know what you're trying to do.
Yeah, just so I can post it,
Yeah.
the image, and then we can paste it. Can I paste it? Upload from URL. Yeah, upload from URL. Let's go here. Okay, so we have an image.
Cool.
Yeah.
Nice.
So
So
now,
pick a color if you can.
so now there's
To
no,
figure out.
no, there's no drawing. Where's the drawing? Where's the color? Color palette. Basics. Okay, so now this
Change color, yeah. There's a change color, so that should work.
color change. What does that do though? No,
I
that's
don't know, it
just
should bring.
that's an overall thing. Okay, online image.
Oh, I see. Oh, this is an image processing, not a drawing tool.
Okay, so image.
Go like MS Paint or something. You can't show MS Paint on. You can share Paint.
Oh yeah, otherwise yeah, okay, I'll just open up my my GIMP and then we'll just do that there.
Yeah, GIMP is fine.
Well, it's just because the reason I was doing that, I have to like I'll share the other one. Okay. Okay, yeah, I'll do this right here. All right. And I'll share the other stop sharing. I'll share this one here. And well, yeah, that's another fun thing. You could also share as well if you want to do the drawings. It's up to you. I'll go to well, actually,
yeah, I might be able to.
or
I'm
yeah.
I'm kind of set up here to do it. So
Okay.
oh no, like it'd be fun for you to do it. Pretend you're in kindergarten and I'm showing you a coloring book and we're gonna color something.
Yeah, yeah,
So I want kindergartners to be able to do this.
Yeah, and the thing is, I also have a actual notepad. Okay, where's my GIMP go? Okay, you can see my GIMP?
Yep.
Okay, so I'm gonna connect this here so I can actually draw.
Oh, good.
I actually have a drawing thing.
Oh, that's gonna help.
Okay, I just need to connect it, and then we're gonna do some actual.
Yeah. So you're gonna pick red. Pick red. No,
Okay.
don't. Yeah. Pick a red color. Yep.
Okay. Let's go with red.
Just bright red.
Okay.
Okay. Now draw a circle. So go from the North Pole. Kind of draw a circle around where you see positive arrows, and then go back.
Like that?
Okay. Those are all the arrows going up. Yeah. Now you don't want to go too far. Like in the left, you went too far down. So we don't want to make red where the lines are going left,
down.
right.
Okay.
We only want to make. Okay.
Yeah.
So at the bottom, you see it's also up arrows. So now do the same thing down there.
Okay, and then the Hall sensor will be picking up these as the same. Okay.
It's going to think, the Hall sensor is going to think, it's going to see red. So imagine the Hall sensor sees red when it sees up arrows, and the Hall sensor sees blue when it sees down arrows.
Okay, so we've
so now change to blue.
So this is actually worse than I could have imagined that guy doing this.
Yeah.
Yeah, I thought there was at least something, but the guys they're mentally why does it just click it?
He just doesn't understand.
Yeah.
He is actually he's calling his drawings real. when they're fake, they're projections.
Okay, now
They're not real. I mean, they're real, like, but they're not. He's calling it the real, but it's not real. So now do the same, like draw a circle. Just draw a circle around all the down arrows on the left and on the right, but don't make it too big. That I
yeah,
guess that's good enough, right?
and then yeah. So this is
Like
all he's
that.
doing.
Yeah.
So there's
So that
literally
is
nothing.
all it is. So there's my
Oh, wow.
drawing that I gave you, that simulation where there's red on the top, red on the bottom, and a blue tube around the middle.
Mm-hmm.
Up arrows are red, down arrows are blue. That's the Hall sensor can't see the magnet. You can imagine the Hall sensor is really tiny and it's maybe the size of one arrow. The Hall sensor can only see the arrow.
Okay, so is he gonna sue
Right?
me?
Imagine.
Is he gonna sue me copyright because of this drawing, or?
Yeah,
Oh, man.
he's gonna take this video down.
Alright.
Right?
Okay, this is
We replicated a figure from his paper using a kindergarten coloring technique.
No, this is good. No, this is why I like your channel.
Yeah.
You explain the same thing in like 7 different ways until finally it clicks. I'm like, okay, this is
Thank you.
this is-
Yes.
it's ridiculous.
And I have to do that to myself too. I have to explain it to myself 7 different ways before I understand it. So
Okay.
I'm glad you appreciate that. That's good.
Yeah.
I'm not repeating. I don't repeat myself. You can't
No.
say I'm Ken Wheeler.
No,
I'm not Ken Wheeler, right?
You know, I listened to him a lot before, and then I'm like, after like 200 video, I'm like, he's saying the exact same thing he said.
Exactly. I
It's like-
repeat myself when I'm under stress. I repeat myself.
No.
You know that.
Maybe. I haven't listened to him in a while, but I think ever since he just can't accept that the ferrocell isn't the magnetic field, I don't like, it's just spectral lines. Like, I don't know. You and
No.
that AB science guy literally.
We
made it.
that kind of, we put the I did the same thing with the ferrocell. I demystified it. In this right here, I demystified
Yeah.
Mr. X's profound revelation. I demystified it.
Yeah, but
right
again,
here.
but
This is it. This is all it is.
Yeah.
You can take any magnetic field
Yeah.
and do what I just told you to do, and you're going to get the pictures that he is showing in his paper.
Yeah. So basically, it's like
Right?
there's literally nothing special. And
Literally.
This is where the spook sensor comes up, because it's like, why is he making a 215 page document
Yeah.
on this? And he admits not understanding magnetic field. So like, what is that?
Or math.
Oh, this.
math.
Yeah, because this is pretty ridiculous. So now I wanna quickly, I'll share the other screen now, and then let me know if whenever you want to share screen, you feel free. But I'm gonna go to.
No, we're good. It's easier if you do it.
Yeah. You can just lay back. Okay.
I wasn't on Teams before. I thought I was and I wasn't, so that was my bad.
No
But
worries.
this is good.
Yeah, so I'm gonna just post this image in my Telegram. So I use Telegram as like basically before I upload to
That's so
YouTube.
cute.
Yeah, so I put it that there. I'm gonna put it also on this is the Hive. This is like it's like X, but it's on Hive.
What's Hive? I don't know what Hive is.
That's the one I was trying to get you on. So I
don't know what it is.
It's it's a blockchain. It's been around since like 2016. It used to be called Steam, and then they got hard forked. Like, do you know what a hard fork is, or no? I have a video overview of what Hive is for people to.
I did do some NFT stuff with my cousin.
Yeah.
We did some NFT stuff. I don't know if you remember that.
Yeah, no, yeah, I saw that. Yeah, yeah, you did some.
So I'm on the blockchain.
No, I understand, but like the Hive is probably the most like underrated. It's like the biggest hidden gem in all of like.
Is it Hide or Hive?
Hive. So if you search up Hive,
Like a beat.
Here's an overview I made about it 3 months ago. If you ever want to look here.
Yeah, I'll check that out.
So Hive cryptocurrency and overview, and how to sign up. Basically, there was a big battle between Justin Sun. Like, I'm not sure. Do you know the Tron blockchain? That's like one of the biggest ones. Anyways, there was some the collusion going on trying to take down Steam, and then the community just forked. So basically, think of Hive.
Oh, I recognize that guy.
Yeah, this guy. Yeah, he was a billionaire that tried to take over, and then the community they just forked away. And then apparently, I was told that he was crying in the DMs, like because he couldn't get his way. So a billionaire that couldn't get people, and he was offering people millions of dollars. They wouldn't want it because you wanted free stuff. Anyway, so Hive, it's a decentralized, like, just think of it as a giant database. Like, it's literally just a giant database. If you go to HE Explorer, I think, or let's go to my site, Peak MES. So to give you an example why I like this the most, just go right here. So if you go to my channel, and I made yours as well, just so nobody steals it,
Okay.
your username. So I've peeked at
Great.
MES.
Thank you.
So this is,
Okay. Thank you.
so yeah. So think of it this way. So this website right here, this isn't Hive. This is running on Hive. So all the data is on Hive. So I can go into here, change the URL to another website that uses Hive. Go to Estancy, and it's the exact same
Yeah.
content. So the websites don't own the content. So all the websites are skins.
Oh.
And here's my there was me and John
Cool.
Hudson a few weeks ago. Yeah.
I saw that picture.
Yeah,
You
there's
must have posted it. You must have posted it on YouTube or something. I
yeah,
saw
yeah,
that
on
picture.
YouTube, yeah. But like I said, I
Okay.
also post on FreeSpeak, so that
Mhm.
again backed up, decentralized. So like this stuff can't be deleted. Like I don't know.
Mhm. Okay.
And yeah, so
It's
yeah.
Is it on the blockchain then? Is it on
Yeah.
blockchain?
It's blockchain
Okay.
with zero fees.
Yeah.
So it's like there's zero fee blockchain.
Yeah.
You can post.
Okay.
So it's made for social media. But yeah, and to give you an example, again, I can keep going on and on. Hive.blog. I can keep going using any website that uses Hive. So if you don't like a specific website, or if the website censors, you just go to another one. Like imagine someone took down your YouTube, but then you just use
All right.
YouTube
Yeah.
dot FractalWoman, and you can make your own.
Huh.
So what I'm trying to say is,
Okay.
yeah. So and
I
yeah.
like that.
So
And there's no way of like suing someone
No,
for
there's
copyright infringement or anything.
no. There is some plagiarism stuff where they can just, all they can do is downvote you. So if you go to make a posting,
Yeah.
these people are doing that.
Yeah.
But that requires getting the community to actually downvote. But your
Okay.
post will always be there, even if they.
So one person doesn't like what I posted, they can downvote me, but no big deal.
Yeah, and downvotes
Yeah.
don't do anything unless you're
Yeah.
a whale, anyways. But like your post,
Okay.
so this one right here, and each post of each time I upvote you, you make probably like 20 cents USD. My upvote
Oh, yeah?
currently, you can see my upvote is worth.
Yeah.
My upvote is probably, how do I check the stats of my upvote? My upvote's probably worth like 30 cents right now at like bear market prices. It used to be worth like $10.
And it's what
And you can see everyone's worth it.
Ethereum? What's the
No, it's
what is
Hive.
it?
Hive.
Well,
Hive.
the Hive is its own. Hive is like Ethereum, blah blah blah.
Yeah, but it's zero
Or-
fees, and it's a 3-second
Yeah.
transaction. It's made to be text, like only text database, and so like it's made to be super fast, and
What do
yeah.
you mean only text database? I don't know.
Like
What do you-
Ethereum has smart contracts like built in, like
Right.
like super advanced ones. So what that means
Yeah.
is each time, like the nodes, the ones that basically keep up the blockchain alive, all the people that stake and like every time you post it, all these different nodes have to like all have a consensus of everything, and then put it together. Like they would need to basically run every single smart contract
see.
themselves, and then put it here. This one is just text, and then they use layer 2s for like most of the smart contracts. So basically, like think of Ethereum as like a giant computer.
Yep.
That you could do a lot of stuff, but it's very costly. And you could see, I'll show you how much Hive. I think I had over transactions. So on Hive, I made over 600,000 transactions. If you compare that with Ethereum, that would probably cost me like $1 million, $2 million, and it cost me zero. I mean,
Wow. Okay. I like it already.
And you earn money. You can see, and the thing is, you can see everyone's worth. Like if you yeah. So you go to MES on here. Go to mine. If you go to my wallet, so you can see my wallet. I have about 9,000 USD worth of Hive, and you could the more you have powered
Nice.
up, the more you can upvote and like have influence on the market on the token, like yeah, and so on. But once you start using it, it's pretty straightforward. And I'm actually delegate you right now, so that it uses a thing called resource credit. So if you want to watch the video I made on Hive, it's definitely worth watching it. You can grasp.
Okay, that would be
yeah,
helpful.
yeah.
Yeah.
And then again, I can help you with this. I'm
I did a bit, like when I did the NFTs with my cousin, I learned a lot. I actually tried to, I wrote some code, we got our contracts, but it was just too, like it was not my world. You know what I mean?
No,
It
I
was
understand.
too hard.
Yeah.
It was really hard to wrap my brain around. And I found a lot of, it was hard for me.
Yeah.
I did a lot of stuff. Like I understand a little bit the lingo. I've been out of it for a year or so, but Yeah.
No, I agree,
Just
but those ones that they're like trying to go like NFTs with fees and all that.
yeah.
It's further.
It's
This one is just better social media. It's like literally, it's
okay.
just think of like your posts and then the on Three Speak, for example. Yeah, so like these are just like articles, right? But you could
Yeah.
do ridiculous things. Like I'll give you an example of uh, I, I try to back up things that are important. Like this is for again for my 9/11 research. These are 499 first responders witness testimonies. I'm not done putting them all in there. I use Grok AI to. There's a PDF that I made of 7,000 page PDF. Look how much. Look at this article that I made. I'm not done yet, but look at how many words there
Yeah.
are.
Wow.
306,000 words.
Holy crap.
So and so think of it this way: can any website in the world do this?
No.
Yeah. The
No
only
way. No way. No way.
yeah. So it took me. Yeah. I usually so right now I'm at 135 witness testimonies. I still need to do like 400, almost 400 more. But it's gonna be like a million page article, and a million word article. Okay, and this is on Hive. You can't do this anywhere else.
Okay.
And the reason this website can even host it is because they're not hosting the data that's on the blockchain.
Right.
So
Yeah.
so I can go to
I totally understand that. Yeah. They
yeah,
don't have to host all the
yeah.
words, all the characters.
So
Yeah.
you can create anybody can create websites on it. So you can go to ecsnews.com. I can now I'm using a different website, accessing the exact same data. Okay, this is a giant
Yeah.
PDF.
Yeah.
This is in
Because
here.
people keep asking me if I have a website, and I did. I had a whole bunch of websites, and I shut them all down
Mhm.
because I didn't want to
Pay for
pay
it. Yeah.
for pay for the hosting and pay, every year to renew, and they got more
Mhm.
and more expensive every year. And I'm like, I'm, a year away from retiring. I have to conserve my resources, and so, I took down my websites.
Oh.
Hopefully I copied all the information. I have all the information. I could recreate everything, but
Mhm.
um, but I would still like to. I think this looks like a good option for me, actually,
Yeah.
for all the reasons you said.
Yeah, it's
Yeah.
definitely. And the other thing is, you can create communities that can't be censored. Like you can actually create decentralized communities. So I have an MES Science one, like 91 people here. But like, imagine on Reddit, you make like, because Reddit and them, like, they censor, like, they remove communities they don't like.
Yeah. Yeah.
Imagine you have one that nobody can touch ever, and let's say there's a million
Yeah.
people. You can literally start becoming a little micronation, and then you can
Nice.
within the community decide to buy physical land or physical things
Yeah.
where or make a deal with the
Is
physical government because they can't take you down. So basically, this is probably the biggest thing people don't grasp
yeah.
about it. Yeah.
Dana, do you hear that? I just want to make sure Dana hears about that, because she's very much into creating communities and
Yeah.
connecting people and that sort of thing. So
Yeah. So
we'll definitely have a look at this.
Yeah, I have three communities. I have MES Science, MES Conspiracy, and MES 9/11 Truth. Just
Yeah.
because I got banned from the 9/11 Truth one on Reddit, and then
Yeah.
their actual one got taken down, like the main. Anyways, there's a bunch of spooks everywhere. And I actually have a spooks database. I have a spooks database for 9/11, but that's for another day. I have I think over 70 people in my database. But anyways, that's for that's for another day. That's for another day, and yeah. But this is it's been great. So basically, this entire thing we're talking about, I was hoping that there's be
Yeah.
like some sort of actual real drama. It ended up being this image.
Ridiculously, cartoonishly simple, kindergartenish simple. I actually was going to make a coloring book
Mhm.
for kids with arrows.
Yeah.
With all the different magnetic, with two magnets and the ring magnet, and they would color in the arrow. All the arrows you point up, color red. All the
Mhm.
arrows pointing down, color blue. All the arrows that are pointing sideways, and that's the key. If the arrow is pointing if the arrow is pointing sideways, like the ones near the top that are going
Yeah.
like
Yeah.
sideways, you wouldn't color them anything. That's where
Oh,
you would
the
find that.
blob. That's why there's
That's where
the difference in there. There's a
yeah,
gap. Okay.
yeah,
And
yeah, yeah.
and the other thing is, like, is there anything actual practical about it? Because like the one that you made, like, so the reason I like your isopotential ones, because it has a physical meaning, like in terms of
Yes.
you actually have like little magnets go that direction.
Yep.
Again, there's pressure gradients. Yeah.
Exactly. That has meaning. If the other ones, if you place a magnet there, if you place a magnet in a horizontally where the arrow is pointing sideways,
Yeah.
that magnet is going to turn sideways. It's
Yeah.
going to point, right? So so on its own, left to its own devices, a magnet is going to turn to align with the magnetic field.
Mm-hmm.
So, but the Hall sensor is attached to your hand that's holding it. You can hold it steady. You can hold it steady and make measurements that are not normal in the true sense of the word normal.
Yeah.
They're not normal. They're not real. Like in the mathematical sense, normal. They're not normal. They're projections, which, and the thing that Mr. X noticed is that they match the electron orbitals, but he could have got that from my channel because I already noticed that even without holding the Hall sensor parallel, I know, or in one orientation, I noticed that the isopotentials look like electron orbitals. So I already had that insight. I didn't do what he did, but I was able to use Michael Snyder's software to get all the electron orbitals in a different way. So I didn't need to do that. But in the actual electron orbitals, the electron orbitals are, some of the electron orbitals are projected. Some of them are the normal way, and some of them are projections. So that is true. So they are, the electron orbitals, I think, are kind of funky.
Yeah. Oh, so
kind of funky.
Yeah, that changes. Yeah. I just realized that. Yeah, because
So that is an insight that he had.
Yeah. This one right here
is different. So those are Michael Snyder's. So I am able to, using his software, I am able to reproduce all the isopotentials, but some of the magnetic configurations aren't possible with magnets. So here's where the analogy breaks down. Regardless of how you hold the sensor, there is no such thing as a magnetic monopole, you know that. And so you cannot get the image on the left. You cannot get the s orbital using magnets. You have to use single charges.
Yeah. That's what
so you want to imagine, instead of these being magnets, these are charges. So the blue and the yellow. So let's say yellow is positive and blue, whatever. Blue is negative. Yellow is north. North and south and plus and minus are the same thing. Right? They're the same thing. And that is something I'm going to talk about soon, because I am wrapping my brain around the possibility that charges are magnetic monopoles. Charges, okay, I'm going to tell you this. You're the first person I'm going to tell this to, and you're going to get it right away. Okay. Charges are monopoles and magnets are multipoles. Simple, right?
Yeah, that's the first video I actually made of yours. On my MES physics, it said the magnetic field resembles the electric field of two bound charges.
Yes, there you go. That's all it is. So Maxwell's first equation is the equation of monopoles, and Maxwell's second equation is the equation of multipoles. So when they say a magnet, there's no such thing as a magnetic monopole, they're saying there's no such thing as a multipole monopole. It's ridiculous.
Yeah. There's no thing as a monopole multipole. Monopole multipole.
There's no such thing as a monopole multipole, which is obvious.
Or a multipole, or a multipole with one pole. Yeah, I think a multipole with one pole. Right. That's no such thing. Okay.
Right. No.
Yeah.
If you think of positive and negative charges as poles, they have polarity. That's a polarity, right? So the first equation there is instead of saying it, I don't know what they call the first one actually, Gauss's law or something like that. Not Gauss's law. Maybe it is Gauss's law.
It is Gauss's law.
So instead of calling it Gauss's law, I hate when they name things after people.
Yeah. I
and
heard
Mr. X wanted me to name his thing after him. And in the email he said, how they name, they never talk about relativity, they talk about Einstein's relativity. He insisted, and that was part of why he came after me, is because he insisted. I refused to do it. In the email I said, I'm not doing that. I'm not naming anything after anyone, let alone you, right? And so I don't like when they name things after people, because I cannot relate names of people to physical laws. Call it the law that it is. So the first equation is the law of monopoles, and the second equation is a law of bound okay, I'm going to say it again. The first law is the equation of unbound monopoles, and the second equation is the equation of bound multipoles. So the difference between a charge and a magnet is a magnet, the charges are bound. They're bound to the atom. They're bound to the metal in the, they're bound. So when charges are unbound, the first equation applies. When the charges are bound to each other, right? And only positive and negative charges can bind to each other. You can't bind positive and positive, negative and negative. When two charges are bound, so the picture of the North Pole is a picture of bound charges. So that's how I was going to make a video on that. All the stuff I was doing was kind of leading up to talking about this and how, how we should be renaming the first and second laws of Maxwell's equation to the law of monopoles, the law of multipoles. And that's it. And you're never going to say, oh, there's no such thing as a mono multipole. Obviously, it's either a monopole or a multipole, right? So whenever I hear it all the time, and it makes me want to jump out of my shoes, like when the second equation says that there's no such thing as a magnetic monopole. It's like, what? So what? It doesn't, it's the way they word things. The problem is with the language. I say that all the time. The problem is with the language. The problem is with the language. When they say stuff like that, because of the language, it confuses people.
Yeah.
And Dan is going to say it's by design. They confuse us by design. They word things. They name things after people to make it difficult to understand the concepts. They name things in weird ways to make it difficult to understand the concepts. Like, I don't know if they're doing it on purpose. They're just not doing it. They're not doing it very well.
Yeah,
in my opinion.
Yeah, I think it's a combination of both. It's like it's kind of like, well, we're gonna use AI anyways to sort it out, so we'll just put it all out there.
Yeah.
And they have better AI.
Yeah.
And they have better AI.
My daughter referred to AI to like ChatGPT as the collective consciousness, and you can see it. Like, I'm starting to feel it now because I'm getting so much information, like really good feedback from it. Like, it's getting really good.
But even then that has like some centralized issues there because they can just go tinker something. So even on Hive, there's the AI that you could there's an AI bot that like all the data. Like, and another thing is like ChatGPT, like where are they getting the data from? They usually have deals with Google and all that. And then,
exactly.
And then X, Twitter, where do they get? They have the good thing about X, they have their own data, but their data is closed source. Like, they don't let other people use it. You can't even archive a tweet anymore. Did you know? Like, I learned that recently. And there's a Hive app that's being built that's like an archive one. It's called Archive. So if you go to any any X account, just go go to any tweet. Let's go to the one I just did right here. So let's say I tweeted this one about our live stream.
Our friend?
No, or this what happened to FractalWoman's channel. So if I go to this one, if I go to the and I think because archive.org got sued and so on, so you can't actually archive any tweets anymore. So we go save page. So we're limiting limiting some limitations when it comes to archiving this website. So you can't archive any tweets anymore. And it's been going on for a while, and they're being sued by like $800 million by record labels for stuff like that. So again, and then the question is like, so and to use X's data, right? You would need to pay like $100,000 just for like API access, just for like basic ones a month.
Wow.
And
oh my God.
Yeah. So to give you an example, again, on Hive, you can go and use like all the data. Like, I try to feed. What I actually did was. You know your channel was taken down, right? I actually used a
my channel.
No, what? I mean, you know how your channel was taken down for that day?
How? I'm like, oh no, did it go down again?
No, but it was taken down, right?
You scared me. Yes.
But
no, I took it down. Yeah,
but he was, but then because you had to, like,
because of him.
My channel was almost about to get deleted before, and I had to remove all the videos because I was doing some Pizzagate videos. and that they got. I
Oh, you
was
got in trouble.
well, they were just again, they were YouTube is like I got one strike and I got like 15 other videos taken down. I'm like, oh, I gotta take it down quickly before I get my whole channel taken down. So I understand that. But anyways, what I have done actually, I think last year or earlier this year, I actually made an AI summary of all of your videos up to see how many I've done.
Yeah.
A summary. If I go to summarizer, so this person on Hive, and again, the cool thing about Hive is you can log into any website that uses Hive just by using the browser extension. Like, I don't need, all you need to, that master password thingy I gave you, like the keys.
Yeah.
You just put
Yeah.
it in once into browser extension.
Okay.
You can
Okay.
you can log into any Hive app without just by clicking approve. So I'm gonna go to.
Okay, I'll make sure I copy them to my official important information file. Yeah.
Yeah, so I think I've done this. Yeah, so Fractal Woman, I have done this before. I have summarized all of your stuff before. Like I would go here, and then I would go to in Leo, and then I would just go to like let's say summarize.
Mm-hmm.
Oh wait, I think I've done every single one of your videos, so that they're all on the blockchain. Like all your videos, a summary of them are on the blockchain.
Oh my God,
and it
that's
uses
so amazing! Thank you.
Well, because again, important stuff I make
Yeah.
sure that it's there so that the reason is so then I can search up stuff like
I
think so that the data's there. I don't need to worry about X removing you or YouTube removing
Right.
it. So I can go
Okay.
to threads and just let's see. I'm gonna do a quick check right now. Actually, I'm gonna go out hashtag ask Leo, summarize. Give me a summary of Fractal Woman on YouTube. Okay, let's see. Let's see if it shows up. Hopefully it does. Okay.
What-
This is a robot. Again, it says AI on Hive. Let's see if it loads up. But again, it's not as clean as normal websites, but it's getting there. Anyways, I don't know what's going on. My computer's like freezing up. I'm gonna close some stuff. I think I just have too many things open. Okay. Just gonna close some stuff. But yeah, anyways, I don't know why it's not loading.
Okay.
But it's all right. But yeah, so this is just the AI bot there. Just to give you an example of that. Give me a summary. Okay, FractalWoman's YouTube channel focus on fractal geometry, fractal cosmology, and related topics. Videos provide informational content exploring mathematical patterns in nature, alternative physics like ether, and visual fractal explorations. It's for educational for math, science, and speculative cosmology enthusiasts with a series on sacred geometry and ether physics. No recent updates noted. Okay, this person needs this is like a recent one. But anyways,
Okay.
the cool thing is the data is on Hive and anybody could use it for free.
Nice.
Yeah, so that's
Cool. Well, I appreciate that you did that. Thank you.
Yeah.
I know I gave you permission. I'm gonna tell the world I gave you permission to do whatever you want with my videos. So I did give you permission to do whatever you want with my videos.
Okay. But the other one,
yeah,
that'd be great. And if you can, again, if you ever get on 3Speak, that's where I put all my videos. This one, nobody can delete these. Like, no one. Well, it basically there's no one he can go and sue.
Okay.
It's kind of like so one more thing about Hive before we go further.
So 3Speak is related to Hive. It's on Hive.
No, so yes, there's 3Speak.
What's the relationship?
3Speak is they're decentralized they're decentralized video sharing, but all the metadata gets on Hive. So the descriptions, the text.
I see.
And
yeah, because it's only text, right?
Yeah, and that gets auto posted on Hive, and it embeds your 3Speak video, and you also earn Hive. Like you earn Hive, and Hive also has. The thing people don't realize, Hive also has a stable coin that's decentralized. Like you can earn USD value stable coin on your posts, anywhere in the world. It's like imagine you're in South Africa or whatnot.
Yeah.
And you can earn USD just by posting, and where $1 there is like $100. So if you earn $1 USD.
Cool.
Yeah, and there's a lot of cool stuff that's been going on this platform. But yeah, so like for example, I posted the video, the Hudson one on 3Speak. It automatically gets shared onto, so all the metadata is on Hive, and then I would edit here to put all the longer timestamps, because these timestamps I actually can't put all these on YouTube. YouTube has a limit. So
What
see
do you
how,
mean
you,
timestamps? I don't know what you mean.
no, so see the timestamps to the video? Do you know have you ever put timestamps on your videos or no?
No. Well, I've seen them. I
Yeah,
just never did.
yeah. So you need at least
Hmm.
3. So you just have to end
Okay.
it with a 00, like you have to start with a
So
00. So Captain
okay.
John tinkering with antique, and then you click it,
Do
right?
you have to write those, or can you get, how do you have to write the timestamps, right?
Yeah, they should have like some automated chapters thingy, but I put my
Okay.
timestamps like key ones, like here, this one here, one of a kind aircraft. This guy Alan firing at 20 Orlicon. So I click it, it goes here, and you can also click here. It shows you all the timestamps or chapters.
Oh,
Um,
cool.
but the
That's really
YouTube,
neat.
but there's a limit. You can't put too many text. Like, so I always put a link to the full timestamps. You go here. Also summary. Oh, I thought I summarized it already. I thought I did. So and I summarize all my videos too on the Hive blockchain just because I want.
You see.
I always think what would happen in
So
the future.
I see. Those, so the timestamps are text only, so they can go on the blockchain. Is that, and then obviously the videos can't go on the blockchain, right?
Well, yeah.
It's text only.
Well, this blockchain is focused strictly on text. Videos,
Yep.
they have a mechanism. Well, they have a decentralized video storage where people earn crypto, and I think there should be getting up live there, but 3Speak, they're really big on Hive, like the actual team behind it. So they're like Hive, like one of the biggest people on Hive. 3Speak, right? Or I think it's like called 3Speak. Yeah.
So does it cost anything to get in?
No, there's nothing. You earn. So people don't realize you literally earn money. I've earned more on Hive than on YouTube, even though I have like, so on Hive I have how many subscribers? I have 1,000 subscribers, 1,600. Yet I pretty much make more or as much as my 50,000, like almost 60,000 subscribers. Because YouTube,
Yeah. See,
YouTube
Go ahead.
demonetizes like all my 9/11 videos. Any conspiracy
Yes,
ones?
of course.
Yeah. So, but these ones earn, and you can see how much they earn as well, and you can see big whales too.
And I think,
Yours will
people
do
love
well.
Fractal. People love Fractal. Like they'll see the word Fractal and they'll jump right on it.
Yeah,
So,
and you could go see the communities too. Yeah, you could see the communities.
Yeah.
No, you'll do really well. You'll do better than me. Like I also do. You'll actually do better.
Well, that would be I'm definitely gonna look into this for sure.
Yeah, because like
And like you say, I don't want anyone. This is better for me actually.
Yeah.
YouTube is starting, because of all the things that are happening and because of being targeted and all that.
Yeah.
It really made me think that I shut my channel down because I couldn't sleep after it happened, and I shut my channel down and contemplated whether I wanted to keep it that way.
No.
I did. I contemplated. I said, I have to. And then when I decided, okay, because people were emailing me, where's your channel? So I'm like, okay, I have to put it back up. And then I couldn't do it because I had the strikes against me. Like I told you, and I couldn't get into YouTube Studio to fix it.
Yeah.
So I was like, and I had a long chat with ChatGPT, and we'd try this, and it wouldn't work. And they said, oh, well, you're pretty much screwed then. Like I said, am I pretty much screwed then? And ChatGPT said, well, yeah. But then I realized I found another piece of information where there was, so I tried to make a comment somewhere. I had been shut down. I said, I wonder if I can leave a comment. When I went to leave a comment, it said create channel. So I didn't click it because I'm like, I don't want to create a new channel because I don't want to wipe away my old channel. So I didn't want to click that because I thought, well, maybe it's going to start a new channel for me. And then how do I get my old channel back? But it turned out when I clicked to that, I found the information before I did it. It brought my channel back up, and then I could go back and turn it back on again. But I couldn't get to it. That's the only way I could get to it was I had to turn my channel. It makes sense now. I had to turn my channel, like unhide my channel, and then I could go to YouTube Studio and turn everything else back on. So yeah, that kind of freaked me out a bit. That's when I was I said, well, maybe I don't want it. Maybe I don't want this hassle. Maybe you know, maybe I was going to actually give all my videos to you, which I've already done, but
Oh, that was great. Thank you.
or, you know, say, okay, let him manage my channel. Like I'll do something, like give it to someone else, like to manage. But this sounds way more,
No, just post it. Yeah, even get your daughter to post it. You'll make
well, look,
money.
so you have the video that he wanted to take away from me.
Yeah, and these are and that was interesting though. So even though the guy's a bit out there, he still has a good point. But like the orbitals, could they just be like what's up and down? Like so these are actually like illusions.
they're okay. The ones, so the s orbitals are fine, but you can't create those with. So go to the orbitals. Just stop at where the orbital picture is. Okay, so that picture there. So the s orbitals you can only do with a mono charge.
Yeah.
The P, Z, PX, and PY are all the normal isopotentials. So those the PZ, like the next three columns. Oh, this is the cool part. Like this is I was also going to make a video on this. The N equals 2, the N equals 3, N equals 4. Those are for all intents and purposes iterations, right? So you see, if you look down the PZ column, it's easier to see. So the first one, of course, there's no such thing as a mono multi-charge, right? So the first column is a mono charge. The second column is a dipole, a double charge. North is positive, south is negative. They're bound though, so it's a magnet, not a charge, right? So the first one, you see the red on the top and blue on the bottom. The second one.
Whoops, I think I went back.
Yeah. Okay, that one is, the first iteration. The next one is the second iteration. So the first iteration is inside. You see, you shrink it down.
Yeah, you see it inside.
It's inside.
Yeah.
And then the next iteration is the previous one shrunk down.
Inside.
So, it's got this. That's better to do it like that. Yeah.
Okay.
You can actually, so click on the second one.
Which one?
Or the third one. Well, do the second one. Yeah, N equals 3. N equals 3. Yeah.
Yeah. Okay. This is
So click on it. So make it bigger.
Oh.
I think you can click on it.
Oh, I can click on it?
Oh no, you can't. No, you can't.
No, this is
on the Wikipedia.
Oh, this is Wikipedia. Okay, I'll go to Wikipedia. I was on your site.
Oh, I'm sorry.
Orbitals.
I got confused here. Yeah, go to the Wikipedia page. Just electron orbitals. So on Wikipedia, go type electron orbitals.
Yeah, and I was gonna say another thing.
Okay, it doesn't matter. It doesn't matter.
I was gonna say another thing is electron orbitals, because you use ChatGPT and stuff. Do you ever use because I use Grok? They have projects like where you can upload specific to one project. Do you ever do that or no?
I don't actually. I'm a creature of habit. Okay. So go down till you keep going till you find that diagram.
No, but what am I? Oh no, I think you're.
That's the right page.
Oh no, you're watching the YouTube again. Yeah, so you're a bit delayed.
I am.
Yeah, you're watching YouTube.
Oh, shoot.
So I was already there like 5 seconds ago. And
you sorry. I was checking. I'm sorry. I'm dumb. Now go down more.
Yeah, so basically if you
until you see that other diagram.
Yeah, there it is.
I'm sorry.
There it is.
I did it because I was checking to see if Dana was still online.
Okay.
Yeah, so click on the first one. N equals 2.
Yeah, N equals 2. So that's the
and it'll make that's monopole. The first iteration. That's the first iteration. That's the dipole.
Yeah.
Okay. Then go N equals 3.
Yeah, and this one has it inside.
Right. So there's the previous one's inside. And then now you have blue on top and red on the bottom.
Yeah, so you keep iterating.
So inside, each one, exactly. So this is a fractal.
Yeah.
Like the electron orbitals. So the N, I used to what is this jumping up a level? What does that mean? This is what it means. So when an electron jumps up a level, it's a resonant. It gets to the next resonant frequency, which puts the previous one in the middle and makes a new lobe on top. Right. Yeah. So you can see them, all the iterations there. In the middle, you got the first one, outside, you got the second one, and then you get the third one, then you get the fourth one. And this goes on forever.
Wow.
Like this doesn't stop where the chart stops. This can with some electron, I don't even know, some particle accelerator or something experiments, they can get to N equals 100 or something like that. That's the energy levels, right? That's what the energy levels are. And I never really, until I looked at this chart very closely and saw the iterations, and then I, had a conversation with ChatGPT. What is any, what is the end, blah, blah, blah. And I said, is this analogous to iterations in Fractal? Because, ChatGPT knows me very well, and it knows I want to talk about fractals. And it said, yes, this is exactly iteration of a fractal.
Yeah, that is a fractal.
So,
just the same thing over and over and over again.
Yep, it is 100% an iterative process that creates this, the energy levels. The energy levels are not I used to think maybe they're the isopotential lines were energy levels, but they're not.
Okay, no.
They're not. They're not.
It's
this
actually
is
the resonance.
What is meant. Yeah. And so you can imagine like a sine wave, like a standing wave, and then has 2, and then the next frequency, then is going to have 4. And then it's going to, that. So this is literally, and that's why it's called a wave function. That's why it's called a wave function, because it is a wave-like phenomenon, like a standing wave. Think of it as it's spherical harmonics.
Just the ether vibrating.
Yeah, it is. It's ether. I think it's ether vibrating.
I think it is. Yeah, just
right. I think it's ether vibrating.
And just with Einoldinu's like first with the magnet rotating like experiments, those are just very hard to look away.
I know that's such a simple demonstration. Like when I saw that, I'm like, oh. Now I understand what attraction and repulsion is.
Yeah. So this 100%. one here looks like the lobes that Mr. X had. Would this be like so how would this?
That's just a projection. That's not. That doesn't exist in physical reality.
So this is a projection then. Yeah. So these are actually.
This is a projection. This is just a projection because I don't know why. I don't even know why we need these. It's just when I kind of know why. When they do their experiments, they're usually looking at the, atom or whatever from a certain direction. And so when they send a photon, when they send a light wave in, because I don't believe in photons, they can only send it in a certain direction. So when they send it in a certain direction, you're going to get that projection.
Yeah. So basically, right? No, I think we basically cracked it. This is the real stuff. Yep. This is.
Yeah, the left 4 columns are real.
Yeah.
And ponderable.
Yeah.
And the rest of them are projections. Right.
Okay, I think we've cracked quantum hydrodynamics.
Yeah.
You guys heard it here first, guys.
So what Mr. X is calling real is not real. It's the not real. It's just a projection. So you can't call a projection real. It's kind of like the ferrocell all over again, because Ken Wheeler was trying to say, oh, that's the real magnetic field. No, that's just light reflecting off the nanoparticles that are, lining up like the iron filings, and the light is reflecting off of the little nano needles that form into your eye, and what you're seeing is a projection.
Yeah.
Not a reflection, and a projection of the reflection. So the ferrocell isn't real. Those ones on the right are not real.
Yeah.
But they're used in physics.
Yeah.
So I'm not going to say they're not important, because they use them. They have these here for a reason, because usually they're looking from one direction. And so when you only look from one direction, that's what you're going to see.
Yeah.
Right? And the other one is kind of if you had a sphere around it. So let's say your sensor was a sphere and you're looking from all the angles, the ones on the left, that's what they would be. I think that's maybe a loose,
So basically, like this one here, they wouldn't be able to see this if they were looking at it from all angles.
No, they would look like to the one on the left of that.
Wow. Right? Okay. No. Yeah. That's.
Yeah.
And the question is,
would look like...
the question is, why do they call it separate? Why do they separate these? Like, how do they obtain this versus? Is it different?
I'm not sure why they need all these. I think it's mostly for experimental setups. So they're looking from different directions, I think. I don't know. This is what the spherical harmonic generators generate when you either look around the magnet, the ones on the left, or you look from a specific angle, the ones on the right.
Yeah, and then so you have the 3D models like that you can like, or the code to actually make these, and then to
Yeah.
see how are they actually making this.
Yeah.
Because even though you're saying it's from one angle, but they're showing it in 3D. So how is it in 3D when it's just a projection?
Oh, no. It's a projection, a 3D. So
Yeah.
the projection is, imagine the Hall sensor.
Oh, yeah, I know, I get it.
It goes all the way through.
Yeah,
The Hall sensor, like you do
check
one
every
plane, then you
yeah.
do the next plane, then you go down, do the next
Yeah,
plane.
I got it, yeah.
So it's
And it's all at one
projecting
angle.
you're projecting onto the sensor. So imagine you had a
Yeah.
plane
And it's going from the top down.
that is vertical. If let's say we had a plane that is horizontal and it's slicing through the magnet. And let's say that plane contained a zillion Hall sensors.
Yeah.
And then you did the top, and then you slice through, then you slice through, then you slice through, then you slice through, all the way through.
Yeah, I got it.
And then that's what my software does. Then you reconstruct it into a volume.
Yeah.
That's the volumes that you get.
Yeah. So no, I get it. Yeah. I was just my mind was a bit out there. But yeah. So another question is, so you're saying so the energy levels go when you go down, the energy level is increasing, but then when you go right. So if they have no,
those are
what are they? Because it keeps going on here.
Those are just
there's this one here.
Those are just different orientations of the magnet and different orientations of the Hall sensor.
Okay, so basically,
this is all the combinations of magnet up down, magnet left right, magnet front back, Hall sensor up down, Hall sensor left right,
so
Hall sensor. Yeah.
And then, with this one, where would the Hall sensor be here? Is it always normal to it, or what?
I have to go back to the main page.
Okay.
Like the main one. Which one were you pointing at?
No, I was looking at this N4. So you see this N4S?
Okay, N4. Yeah.
Yeah. So notice.
Yeah.
So if I go,
yeah.
keep going
so that's
to the right.
okay. Great. Okay, so the Z. So the one Z squared. Okay, so that is the magnet oriented up down, and we're scanning up down.
Where's the Z squared? You mean?
Okay. I look at the top of the column. So you see all these numbers. These are all the quantum numbers.
Yeah.
These are all the quantum numbers. So the N is the principal quantum number, the first quantum number. That's the iteration. That's the energy level.
Okay.
Right. And the L, I think, tells you the shape. And the M is the angular. I don't know how to explain it enough. I don't have it in my brain. Like I don't have the words.
No.
You could look it up or ask ChatGPT.
Yeah,
but these are the principal. These are the quantum numbers, and the first one is, the iteration.
Yeah.
Then there's the L. Then there's there's M, L, and M. N, L, and M. Right, and L and M are the radial harmonics. So L and M are the terms for the radial harmonics, and those are the angular components. So they're related to angular momentum supposedly. And then the N number is the energy levels.
Yeah.
Right.
Yeah.
So L and M are the parameters for these spherical harmonics, and that's why, magnets also use spherical harmonics. That's why the isopotentials look like orbitals. It's not because electron orbitals, isopotentials look like orbitals. It's because isopotentials use spherical harmonics and electron orbitals use spherical harmonics. And you're gonna see the same thing with resonant fluid, with wave dynamics. Wave.
Yeah.
So if you had an oscillator in water, it's going to create a wave, and if you have two waves, you're going to get the spherical harmonics of the spherical resonator.
Yeah,
and I'm also in the middle of making a video on that. So I just spherical harmonics is the bridge that bridges all of these different scales together and all of these different fields of study together. They all go back to spherical harmonics. So that is why the figures, the shapes match. And again, that's not, everyone. This has been known for 100 years.
Yeah. So
this is also not rocket.
We're not gonna get sued.
I don't think so.
Yeah, so I was trying to just jump in to say, well, I'm looking at this more from an overview perspective, not the specific details. Like, so that you have the energy level 2. Notice it
Yeah.
just goes to here, and then there's no more. It doesn't have these wonky stuff, and each one ends
Yeah.
somewhere. So as the
Yeah.
energy level increases, there's an
You
increasing
get
level
more,
of
yeah, you
plus.
get more degrees of freedom.
Yeah.
And then some of them haven't been found. I think like there's ones at the bottom where they just haven't discovered them, or they haven't been able to
Oh,
have an experiment that can literally see them.
those. So
And I
that's
don't
really
actually
nice.
even know what experiment they would use to literally see these things. So
Yeah.
the ones at the top, it's kind of like the periodic table.
Yeah.
It actually is a periodic table, and this can be related. The chemists use this. Chemistry, the chemists use this.
Wow. No,
They use this to figure out how bonding is going to happen,
okay.
right? How
Yeah.
atoms are going to bond together. They use this.
That's good.
And actually, I found a video. Someone sent me a video on it, and I didn't know it. I'm like, oh, this is really cool. So it's pretty straightforward. And that's another thing, Mr. X was talking about in his paper, thinking that he discovered it. But, this is common knowledge that the chemists use this phenomenon to help understand how bonding happens in atoms and that sort of thing.
Yeah.
Right. Well, and it's in biology too. Like chemistry is biology. Biology is chemistry, right? I mean, biology is chemistry. So it's a good idea to know chemistry, I think, before you do biology. And maybe it's a good idea to understand this before you do chemistry, which they do.
Yeah.
Right. So, yeah.
No, this is all
Anyways, I have to go. Same. I can't believe we've been talking for 2 hours. This is amazing.
No, it's good. One thing I just wanted to go to show you about the projects thing. So, what you could do, ChatGPT could do as well. You can add your sources here. So I have for example, I put the paper that Einaldini do, just so that you could review all this before any question. So basically, you should be able to do it on ChatGPT, like make a project or something similar, and then feed your info and any other info that you think is important, and then so basically it says review this as well as the internet, just so that that's something just to if you ever get in that. But anyways, so it's great talking to you, and
okay, good.
and again, this is another friend I got on the Hive. He actually says he doesn't want to deal with taxes, so he gets all the rewards. He just tells me to take them. So he posts art. He posts art, some COVID art.
Oh, neat.
Yeah.
Okay.
And he gets a lot of money. Just gives it to me, so that's good. Anyways, and I can help you.
That's nice. Yeah.
Help you.
I don't want to deal with taxes either. That's why I shut off monetization on YouTube.
Oh, okay. Well, if you don't want tax, I can stake your crypto. If you don't want.
Yeah, no. I would give it to my.
Or your daughter. Yeah. Just tell your daughter to do all that.
Let her manage it. She can manage it, and
that'd be great.
I don't want to deal with taxes, so just maybe put it in her name or something. And
well, it's just Fractal,
or just
Fractal, and then she just takes everything. Well, the thing is, you'll be surprised at how fluid everything is. Like you'll be wondering why you didn't do this 10 years ago.
I will probably ask you for help.
Yeah, for sure.
I'll need your help, but I'm sure you'll be.
Yeah, I'll help you out, and
able to help me.
And I'll send you the video tutorial that I made on it.
Okay, thanks. Yeah.
Right. Anyways, that was good talking to you.
Hey, cool. Thanks. All right.
Adios.
Okay. All right. Bye.
Bye, Lori. Leave. All right. Hey guys, Lori is gone, and I'm gonna end the stream right now as well. It's just been 2 hours. Okay, guys. Anyways, thanks for joining, guys. Any other question? Okay, Dana, still online. Okay, Epic's up there. Dana, so then also, you could, you can give your email or tell Lori to send me your email if you want, and then I could just I could help. Like basically, you could be the manager of her account. Thanks for joining, and have a great day. And then you can earn the crypto. I was gonna say I want that sweet crypto cash. Anyways, guys, that's all for today. Okay, Gonzo Johnny, have a good one on Rumble. Anyways, guys, ending the stream in 3, 2, 1, end stream. All right, and okay, I'm gonna stop recording.